Hello everyone and welcome back to our videos. Today we will talk about turning flight and we will mention on the adversarial and its solution. Before an airplane turns, it must overcome inertia or its tendency to continue in a straight line. The necessary turning force is created by banking the airplane so that the direction of lift is inclined. The lift opposes weight have a vertical forces. The centrifugal force opposes the centripetal force. It will give us a horizontal forces. What's the meaning of centrifugal force? Is the force which acts outward from the center of rotation. What about the centripetal force? Is the force which acts toward the center of rotation. What we say before, it's the adversarial. When an airplane rolls into a turn, the aileron on the inside of the turn is raised and the aileron on the outside of the turn is lowered. As we see here, the aileron will go down and this aileron will goes up and this will make a roll. The lowered aileron on the outside increases the angle of attack and produces more lift for the wing. Since induced drag is byproduct of lift, the outside wing also produces more drag than the inside wing. We can see together here the outside wing whose goes down, it will make more angle and increase the drag more than the upper wing. This causes a yawing tendency toward the outside of the turn, which called adverse yaw. Also, as we see in this figure, we have this airplane, and here this the right wing and this the left wing. The aircraft will make a rolling to the left side. When it will make a rolling for the left side, the right aileron will goes down and the left aileron will goes up. The aileron that will goes down, it will make or it will increase the drag more than the left aileron, and this will make or will permit the aircraft to make adverse yaw, and the adverse yaw it will be to the right side. In a conclusion, adverse yaw is the tendency of an airplane to yaw in the opposite direction of the turn. So, what's the solution for the adverse yaw? We have four things that prevent the aircraft from making adverse yaw. The first one, interconnecting of aileron and radar. The second one, fries aileron. The third one, spoilers, and the last one, differential ailerons. Now we will talk about everyone individually, and we will start with the interconnecting of aileron and radar. Coupled or interconnecting ailerons and radar are linked controls. This is accomplished with radar aileron interconnect spring, which help correct for aileron drag or adversarial by automatically deflecting the radar at the same time the ailerons are deflected. When the control wheel is moved to produce a left roll, the interconnect cable and spring pulls forward on the left radar just enough to prevent the nose yawing to the right. The second thing that will prevent the adversarial is the fries aileron. With a fries type aileron, when a pressure is applied to the control wheel or stick, the aileron that is being raised pivots on an offset hinge. This projects the leading edge of the aileron into airflow and create drags. How that come? As we see in this figure, this the neutral position of the aileron. When the aileron raised, the area between the trailing edge of the wing and the leading edge of the aileron, it will have more space or gaps. This gap will make more drags on the leading edge of the aileron and will equalize the opposite side of the aileron. So that helps equalize the drag created by the lowered aileron on the opposite wing and reduces adverse aileron yaw or adverse yawing. The third thing that will prevent the adversarial is the spoiler. The spoilers found on many gliders and some aircraft, high drag devices called the spoiler, are deployed from the wings to supply the smooth airflow, reducing lift and increasing drag. Spoilers are often used for roll control, an advantage being the reduction of adverse yaw or adverse aileron yaw. For example, to turn left, the spoiler on the left wing is raised, destroying some of the lift and creating more drag. The left wing drops and the aircraft banks and yaws to the left. The last thing that will prevent the adversarial is the differential aileron. With differential ailerons, one aileron is raised a greater distance than the other aileron is lowered for a given movement of the control column. This produces an increase in drag on the descending wing. The greater drag results from deflecting up aileron on the descending wing to a greater angle than the downgoing aileron on the rising wing. as we see in this figure, the wing that will rise to the opposition, it will go further than the aileron will go to the lower side, and this helps the upper wing to produce more drag, and this will equalize the drag that produced from the lowered aileron and will prevent the adverse yaw.